Okay. So the slope. This does say 3.5 on yours. Mine was the mess up. So we're really doing 3.5 today. Yours says 3.5. Oh. Hey, guest teacher, do you want a copy of these? Okay. Sorry about that. I skipped you. All right. So slope. Rise over run. Rise over run. Write it down in there somewhere. Rise over run. Anything else you remember about slope? That's it. Rise over run. Ooh, now that's not slope, but that is something else that we're going to talk about real soon. Slope is rise over run. What'd you say, Dave? David, did you say something? Oh. It's a boy's voice from over here, and I assumed it was you. Was it you, Donovan? Was it you, Stephen? Cameron? Was it a ghost? Yeah. Okay. All right. So rise over run. It says the steepness of a line written as a ratio of the change in the y to the change in the x. So it's a ratio, it's division. It's written as the change in the y, which is rise, or the change in the x, which is run. There is something that, as I help you guys, we've been doing this since the first weekly review. We've been doing lines, if you've been doing your weekly reviews. But there's something that I notice all the time is if we have a negative slope, the line should be going down. And when you guys have a negative slope, for example, I'm just going to write it off over here. If you have a negative slope like negative 1/4, a lot of you are treating this as negative 1, and then you're treating it as left 4. You're going like down 1, left 4. But if I go down 1, left 4, it makes a positive line. Why? Right, 2 negatives make a positive. So these here are not equivalent to each other. If I go down 1, I have to go right 4. Or I could go up 1, but then I have to go left 4. 1 negative makes a negative. 2 negatives make a positive. So we have to be careful with our slope on that one. And then if you have a slope of 0, that means it's not going down, it's straight across. Slope of 0. What's that? So positive I didn't write because I hope positive, well, I just write it in here. Positive's hopefully obvious, but negative is downhill. 0 is that way. What's that other one? What's that fourth slope? No, that's not the slope. That's the equation. What's the slope though? So we've got a line that looks like this, horizontal. We've got a line that goes downhill. We've got a line that goes uphill. What's my other line I'm missing? Raylan? Up and down, like vertical. Does anybody remember what kind of slope this is? Ooh, I heard it. Was that you? Undefined, yeah. So there's like kind of your 4 slopes. This says formula though. Formula means we can in x's and y's. So our formula for the slope is the change in the y's divided by the change in the x. y2 minus y1 divided by x2 minus x1. And then when we were doing distance formula also had like x2 minus x1 and y2 minus y1, just in a different format. So if you're not looking at the graph to count rise over run, then you can just use this formula. Okay, so now, Rakaya, what you had said just a moment ago, I think it was you, y equals mx plus b, yeah. So that's slope-intercept form of a line. The formula for slope-intercept form, that's y equals mx plus b. Now what is m? That's the slope. And what's b? And that's the y-intercept. And by the way, we write the y-intercept as 0, comma b. We don't write it just as a number. We write it as an ordered pair, 0, comma b. Okay. Today we're just going to really mainly have lines in form, but there are other forms of writing a line. Slopes of parallel lines. In your weekly review this week, I asked you to find a parallel line. And that was in preparation for this. If we have two parallel lines, and we're talking about their slopes, which is the steepness of the line, what can you tell me about the steepness of these two lines if they're parallel? They're the same. They have the same slope. So it says right here, same slope. Now, slopes of perpendicular lines, it says what to do here, but slopes of perpendicular lines are a little bit harder to just look at and figure out. Slopes of perpendicular lines, here's a hint. If you imagine this on like a coordinate plane, and these are perpendicular lines, here's a hint of something that is always true about perpendicular lines. You see, if one of them's going, let's try it again. If one's going down, what's the other doing? Going up. If one has a slope of negative, what's the other one have to have? Positive slope. Like they have to have one positive and one negative slope to be perpendicular. And then something else about perpendicular that you can't necessarily see from this graph is that when you multiply the two slopes together, the value is -1. So what's that mean? They are opposite reciprocals of each other. Opposite means one is plus and one is minus. Reciprocal means we take the numerator and the denominator and we flip them. So they have to be opposite, meaning plus or minus different, and flipping different. You have to do two things to find a perpendicular slope. So let's look at the slopes in these examples. Example 1, determine which of the lines are perpendicular. We're going to do that by finding the slopes of each line. You might be able to just guess, but we're going to justify our answer by finding the slopes. So line A. Line A. Slope. You can either count rise over run, or we can use 2 points on the line. You guys choose what you want to choose. I'm going to do the formula so that you've seen it 8 times today, okay? But you can choose to just count rise over run if there is a picture for you. If there is not a picture for you, then you're going to have to use the points, which are -3, 2, 0, 3. So I would go 2 minus 3 over -3 minus 0, which is -1 over -3, which is positive 1/3. Is that the same answer you got? Positive 1/3? Yeah. When you counted rise over run? Okay. Line B. Here's my line B. I've got -1 minus 0 over 0 minus 2. And I get 1/2. Some things as you're writing down your slopes, you want to be careful about. I look and I see that this line is positive. And I look at my slope and I see my slope is positive. If looking at the line and your slope don't agree, then maybe you've just made a silly mistake. Line C. You can count your rise over run, or I could just subtract my y's over subtract my x's. So -5 minus -4 over -1 minus 1. Get -1 over -2. I get 1/2. Line D. Run out of space on my paper. 0 minus 2 over -2 minus -3. Get -2 over 1, so I get -2. All right, so now we have to decide which lines are below, which lines are below. Alex, do you see any parallel lines here? Which lines? Okay, so we're going to say that B is parallel to C. Why? Same slope. Are there any other parallel lines, Donovan? Are there any other parallel lines besides B and C? No. Okay. So now we're going to look for perpendicular lines. So I think you might think that D is going to be one of them. Anybody think D might be one of them? It's the only one that has, the rest of them have positive slopes. Okay. What we're looking for is in their slopes, they have to be opposite and a reciprocal. Aaron, do we have any opposite and reciprocal slopes here? D and what? And B? Yes. So I'm going to say B is perpendicular to D because their slopes are opposite, reciprocal. There we go. John, do we have any other?
Yes.
We do? Yes. What? D and C. Okay, so C is perpendicular to D, same reason. And I believe there was a theorem that we had in the last section that said if two lines are parallel and one's perpendicular to one line, then they're going to be perpendicular to both lines. All right, so now what I want you to do is I want you to find line A, B, C, D in the next picture. And I want you to, find the slope of each of those lines. And I want you to decide if there's any perpendicular, any parallel sets. So you try. I do want you to list their slopes. You don't have to use the formula if you're using rise over run, but you do need to list their slopes. Maggie, do we have any parallel lines? You're still what?
I was still working for them, but yes, we have parallel. Line A and line
Okay.
B.
Oops. A and B are parallel. They have the same slope. Austin, any perpendicular? Is that a question or an answer? Okay. Why? Because why? Why are they perpendicular? Well, then why aren't A and D perpendicular? Well, how do you know that? How do we know? What do we do? What do we say about the slope? What did you do it? What? Say it again. I couldn't hear. I was coughing. They are opposite reciprocals, yes. All right, handle that. Yeah? Let's add something else on. Second page. We're going to write the equation of a parallel line. So this says we're going to write the equation of a parallel line through point -1, 1 that is parallel to the line y equals 2x minus 3. And we're going to check by graphing both lines on the coordinate plane. Okay? So the first thing I want you to do, just right now for this example, first thing I want you to do is I want you to graph y equals 2x minus 3. We've had to do this on every single weekly review I've given you for the past 6 weeks. Some weekly reviews, multiple times we did the same question. I've always asked you to explain how you did it. So most of you chose that the slope is 2, and then the y-intercept goes at 0, -3. Most of you chose that method of graphing. So we go to 0, -3. This is our beginning point. Begin at B. Begin. And then from here we're going to move. And how much are we going to move? Up 2 over 1. Up 2 over 1. 2. And what did I not give you today? Straight edge. Well, you're going to get some for yourself. Get some for everybody.
My bad. I don't want to get up in the middle of the question.
Well, I'm sometimes I Can we get you in, Ryan? Did everybody get a straight edge? Except for me. All right, so what is something we definitely know about the new equation? It has the same slope as this equation. So our new equation, parallel equation, our slope is going to be the same as this one, which is going to be 2. That I know. What's something else that we know about the new equation? Alex. It will, but I don't know what the y-intercept is yet. But there is something in this first sentence that tells me for sure something about that first equation. Has to pass through -1, 1. So I know it's going to go through -1, 1. I know it's going to pass through here. I should be able to graph that new one now, right? Okay, because I'm going to start here and I'm going to use my slope of up 2 over 1, up 2 over 1, up 2 over 1. What are you discussing? It's not even that hard. You thought it was going to be hard? Nah. However, I'm going to show you algebraically how to find this equation because sometimes it might be more difficult than what you're thinking, but not always. Okay, so the parallel equation, I'm going to show you algebraically how to find it. We know that the equation is y equals mx plus b. We know the m has to be 2. we also know a point at negative 1, 1. So m is 2, x is going to be negative 1, y is going to be 1, and we're going to find b. Now, I can look at the graph and tell you the answer for b already. Just saying. I can look at the graph. However, I'm going to show you algebraically. So what we're going to do is we're going to plug in 2, negative 1, and 1 into m, x, and y, and we're going to solve for b. So, the y is, and let me just write this over here. The y is 1, the m is 2, the x is negative 1, and we don't know b. Even though I can look at the graph and tell you the answer right now. It's right here. There it is. Okay. So now we're going to solve this. So I have 1 equals negative 2 plus b. How do I get b by itself? Add 2. So we get b equals 3, or 3 equals b, which is b equals 3. So then we will have our equation by plug in the m, which was 2, and the b, which is 3. Y equals 2x plus 3. Done. Let's do another one. Let's do the algebraic part first, and then we'll check it using the graph, because that's really how I wanted you to do it. But all right, so the first equation is y equals negative 2/3 x plus 1. What is our slope? It's the negative 2/3. What is our y-intercept? 0, 1. I'm getting ahead of myself. You guys totally want to graph it now, don't you? You totally do, don't you? Okay, well, let's just graph just this one. Negative 2, right 3. Negative 2, right 3. Negative 2, right 3. If I run out of space and I want to keep drawing dots, because I like drawing dots, I can always switch where the negative is. I can go up 2, left 3. Up 2, left 3. Up 2, left 3. Still be on the same line. Okay, so my parallel equation. I need a slope. What is the slope I will be plugging in? Negative 2/3. I need a point, which is given to us in the instructions. Negative 6, negative 4, and then I need to solve for b. So I'm going to use y equals mx plus b, and I'm going to plug in m, the y, and the x. So negative 4 equals negative 2/3 times negative 6 plus b. If you need your calculator to multiply a fraction, then you have that baby handy. But for me to go find my calculator and type it in, I could have done it by hand by now. Just saying, I feel like being able to do this multiplication by hand is going to be way faster than even pulling my calculator out. So when I go multiply fractions, I have to put the 6 over 1, and I have to multiply straight across. So I get on top a positive 12 over a 3. And then I can simplify that. What is 12 over 3? Okay. Nope, that one's... And then I'm going to subtract 4 from both sides, and I get my b equals 8. So then we're going to plug in m and b. Y equals negative 2/3 x plus 8. Oh. Where am I not getting a negative 8 from? Oh, I just forgot the negative. I'm sorry. Thank you for paying attention. Appreciate it. I only make one mistake per year. That was it. That's funny. Okay. So now we're going to begin to graph this one where? Where do we graph this one? -8. And then we go down to over, oh no, I'm like off the graph. What should I do? Go up and left instead, okay. Up and left. And then as I'm connecting this with a straight edge, for checking my answer, I need to make this through that point that it told me it's going to pass through. -6, -4. It does. I must have done it right. Yay. Okay. All right, I gave you a really hard one for the next one. Unless you're in Algebra 2, then it should be easy. If you're doubling up, it better be easy. No pressure. Who are my double uppers? I know 2 of you. Are you one? You're not. Just 2 of you? Oh, okay. So no pressure. All right, write the equation of line passing through the point 7, 2 that is parallel to the line y equals 8. Check by graphing both lines on the coordinate plane. What is this? This y equals 8 thing. I do not think I gave you any of those in any of the reviews yet. I don't think I did. This is in the form of y equals mx plus b, by the way. It is.
And the slope is like 0.
Yeah, the slope is 0. This one is slope 0. So y equals 8 has a y-intercept at 0, 8. And the slope is 0 means it goes up nothing over 1. Up nothing over 1. Up nothing over 1. Every single ordered pair that will be on this line has y equal 8. Now it has to pass through the point 7, 2. So 7, 2 has to pass through that point. Has to be parallel to this equation right here. There's 2 ways we could do it. We could do it graphically or we could do it algebraically. Parallel equation. If the slope has to be 0 and I plug in my ordered pair 7, 2, so 2 equals 0 times 7 plus b, what does b have to equal? What does b have to equal? 2. So my equation is y equals 0x plus 2, but I don't write 0x. Y equals 2. And that should be a horizontal line that passes through. We feel okay with this. Last example we're doing today is the next page. We're not doing this whole packet today. We're doing one last example. Write the equation of the line passing through the point -3, 1 that is perpendicular to the line 2x plus y equals 2. So this one we're doing perpendicular. First of all, I'm going to look at 2x plus y equals 2, and that's not really the form that I like to graph in. What should I do to change this into that form? Matthew, what should I do?
Subtract your property.
Ooh, look at him giving me a property. What do I actually subtract?
2x.
Perfect. So I'll have y equals -2x plus 2. That was where my slope is -2 and my y-intercept is 0, 2. So I begin at 0, 2, and then I go down 2 over 1, down 2 over 1, down 2, right 1, down 2, right 1. We're going to do a lot of the same work that we did on the parallel ones, except for one thing. Perpendicular equation. My one thing is my slope is now going to not be the same. It's going to be opposite reciprocal. So if I have -2 as my original slope, my new slope has to be opposite of that and reciprocal of that. So negative, the opposite of negative is positive. The opposite, or the reciprocal of 2 is half. So it's going to be positive 1/2 for my slope. The point, the xy that I use, is -3, 1. And then we're going to solve for b. It's the same steps. So we'll do y equals mx plus b, and we'll plug in half for the m. My y is 1. My x is -3 plus b. 1 equals -3/2 plus b. So I have to add 3/2. What is 3/2? Same as, like, mixed number? 1.5. So if I add 1 plus 1.5, what do I get b? 2.5. So y equals, we're going to use our perpendicular slope, 1/2 x, plus my new y-intercept of 2 and 1/2. So I'm going to start at 2.5. Of course, it's like right there by the other point. And I have to go up 1/2. If I go up 1 full unit, I'm going to end up at a half unit again. Over 2, I'm still at a half unit because we started at a half unit. There's probably an easier way for me to graph this second one. What point should it pass through? -3, 1. So if I go to -3, 1, it does look like it passes through there. I guess I could have started at -3, 1 and went up 1/2, and then I wouldn't have had to deal with all those fractions. I didn't think about that till I was done already, sorry. So this would be the answer. Okay, how about this one? Write the equation of the line passing through point 1,5 that is perpendicular to the line y equals 1/4 x minus 3. I'm going to actually just do the algebra this time, okay? For real this time. So if I'm looking at the original line, my slope is 1/4. We need the perpendicular equation. So I have a perpendicular slope. Ryan, what's something I need to do to take 1/4 and change it into a perpendicular slope? Make it negative. Excellent. And then Emily, what also besides make it negative do I need to do to change my slope? What? Okay. On the front page, we underlined it right here. And it says opposite. So what do I still need to do? I already did the opposite part. Is there 4? So I'm just going to write 4. You can write 4/1, but I'm going to write 4. So we're going to use our new slope of -4. Our point, which is our xy, is 1/5. And we have to solve for b. Y equals mx plus b. So we plug in y, 5, m, -4, b, no, x1 plus b. So I get 5 equals -4 plus b. Add 4, and b is 9. Who knows what's going on? Let's check it by graphing. So my original one, I start at -3, up 1, up 1 over 4. Our new one, we have to start at 9, go down for 1. Really, to just check these by graphing? To check these 90 degrees. You could take your Post-it and put it in there and just make sure it actually makes 90 degrees, which it should if you did a good job of graphing it in the first place. I'm just going to skip the last one. We've done a lot of these examples, and you have a worksheet for your assignment. I'll pass that out. And you guys can start on it in class. Make sure you understand it.